So today we're going to talk about our last lesson for Chapter 7, which is geometric sequences as exponential functions. We're working on the same two skills that we've been working on, and we are going to talk about geometric sequences. So your vocab term for today is a geometric sequence is a sequence in which each term after the first is found by multiplying the previous term by a constant r. That constant r is the common ratio. And so when we think about this here, we can think back to when we talked about arithmetic sequences. Arithmetic sequences were sequences created by having a start value and then I have the same addition or subtraction between each term. So I might have a common sum of 2 where I'd have my starting value and then I'd add 2 each time. Or I might have a common difference where if my starting value is 4 and then I take away 2 each time. This time, with our geometric sequences, if we were to graph them, we would find that they are exponential curves instead of being linear like our arithmetic sequences. The other piece that we need to know with this vocab term is how to write an equation for the nth term of a geometric sequence. So you should have this written in your notes here. When we look at this here, we see that a sub n, so that means any term in the sequence can be represented by taking our first term, a sub 1, that first term, and multiplying it by our common ratio raised to the power of that number n, whatever we choose, minus 1. The reason we have that minus 1 is because we want to start at the 0th term. Instead of that starting value, 0th term, a sub 0 would be where we cross the y-axis. A sub 1 is when x is 1. So a sub n equals a sub 1 times r to the power of n minus 1. And that looks similar to when we had the arithmetic sequences. The arithmetic sequences, I had any number can be represented by taking that first term in the sequence, and multiplying it by n minus 1 times the common difference. Instead of a ratio, we had a difference. Very similar structure, just a little bit rearranged to show the different types of sequences. So the first skill that we're going to work on is we're going to recognize sequences and find common ratios or common differences. If I look at this first one here, I have the sequence 28, 64, 32, 16. And some of you can recognize right away what this is, but let's walk through the process of how we would identify this sequence. First thing we'd want to do is we need to figure out, is there a common ratio? If I want to know how I turn 128 into 64, I want to know what I can multiply it by. Well, to do that, I take the second term and divide it by the first. And so if I take 64 divided by 128, I find out that 64 is half of 128. So my common ratio, or my ratio, not common yet, my ratio is 1/2. Well, let's see if the pattern repeats. If I take 64 and I multiply it by 1/2, do I get 32? I do, so the ratio repeats here. This is still times 1/2. And if I check the last one, I have times 1/2. So in this one here, my sequence would be geometric, and my common ratio would be 1/2. My options, when I'm identifying these sequences here, I can have geometric sequences, I can have arithmetic sequences, or I can have sequences that are neither of those. If I look at this one here, well, let's see if we have what kind of sequence we have. 1, 4, 9, 16. Well, if I want to know how to turn 1 into 4, that's either a times 4 or a plus 3. Let's see if either of those patterns match when I go from 4 to 9. Well, 4 to 9 is times 4/9 or plus 7, plus 5. So it is neither arithmetic or geometric, so I'm going to say neither. Because it is neither of those options, I don't have a common ratio or a common difference. So I don't have anything else that I need to write. I'm just going to leave it with the word neither. But there is a pattern here. If I look at this string of numbers, there is a way that they are turning from one into the other. And what's actually happening, it's not arithmetic or geometric, but it is my squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So there is a pattern, but it's not arithmetic or geometric. Now let's look at this one, 7, 10, 13, 16. Well, to turn 7 into 10, and then I want this pattern to continue, well, let's think about it. 7 to 10 is times 10 sevenths, which is not a useful one, and if I multiply 10 by 10 sevenths, I'm not going to get 13. But if I look at this sequence here, I can recognize that 7 to 10 is plus 3, 10 to 13, oh, that's plus 3. 13 to 16, that's plus 3. So I do have a common sum. So this one here is an arithmetic sequence. Let's go arith. And my common sum is 3. The last one, 1, 4, 16. Well, if I want to go 1 to 4, that's either times 4 or plus 3. But then 4 to 16, well, again, that's times 4. So I know that this one has a geometric sequence with a common ratio of 4. R equals times 4. To do that, I could take that second term and divide it by the first. So 4 divided by 1 is 4. 16 divided by 4 is 4. You can work forwards or backwards to recognize how those numbers are changing. One last practice problem today, and I want to both write the sequence and find the nth term. So we're going to come up with some example ones to see. Well, if I go from -1 to 5, that's either multiplied by -5 or plus 6. If I check between 5 and -25, well, that's also multiplied by -5. So in this one here, I know that my common ratio is -5. So I have a geometric sequence. Now I need to write the equation, and I know from my introduction that my equation is going to look like a sub n, so any number in this sequence is equal to the first term times that common ratio to the power of n minus 1. So if I plug in what I know, I can find that any term in the sequence is going to equal my first term multiplied by my common ratio raised to the power of n minus 1. My equation looks like this. Well, now let's practice with it. I want to know what the fourth term will be. Well, if I look up at my sequence, I know that my pattern is multiplying by -5, so I can find the fourth term by doing it that way, and I should find that it's 125. But let's practice using our sequence here, or our equation for our sequence. I want to know a sub 4, the fourth term in this sequence. So I'm going to have my first term times my common ratio raised to the power of that n value 4 minus 1. Now, one thing to remember, and it's especially important if we have a negative r value, is that we want to have that r value in parentheses because we are taking that common ratio, and we should notice a pattern that it goes negative, positive, negative, positive, negative, positive. Okay, so moving back to our equation here, I can simplify that n, or the power term, so I get -1 times -5 to the power of 3, which gives me -1, well, if I use a calculator or if I use my brain, -5 to the third power is -5 times -5, which is positive 25. Positive 25 times -5 is -125. And then my last step, when I simplify, -125 times 125, -1 times -125 is a positive 125. And that matches what I found when I did it just continuing my pattern. Let's do one more practice where we're going to take, we want to find the 50th, no, let's not do 50th. Let's do the 10th term. Let's do the 10th term in this sequence. So now I want to find a sub 10. I'm going to do the same process as before. That first term times my common ratio raised to the power of the term I want minus 1. If I simplify that exponent, I get the 10th term is going to be equal to -1 times -5 to the power of 9. And at this point, I can use my calculator. Oops, pause for a second. With my calculator, I can type that in, and I find that my final answer is positive, because I know that that even number is going to be a positive value because of my negative times a negative. It is 1,953,125. My final answer for the 10th term would be that value there. Make sure that you know how to use your calculator tools appropriately, because you're going to be asked to do similar things on the test coming up. And your homework job for tonight is a short assignment. It's just 10 questions. Number 34, I really like. Think about it carefully before you check the key. 43 through 46, one or two of those ask you to think back and use your skills from the last unit. So make sure that you're putting everything together as we move forward. This is your last lesson in this chapter, so be ready for a test coming up quick. Check the schedule on Teams if you're not sure when you're going to be taking that test. Because the test is coming up, make sure that you have all your homework for the chapter turned in and that you've completed the review activities, the practice test or the Delta Math tasks. Thanks, ladies and gentlemen.